Good morning, class 10th. As we have done the proving of basic proportionality theorem or Thales theorem in the last video. So just for a recap, in triangle ABC, if DE is parallel to BC, then according to Thales theorem or basic proportionality theorem, AD upon DB equals to AE upon EC. This is basic proportionality theorem. Now if we add 1 on both the sides, left hand side as well as right hand side, and take the LCM. So left hand side LCM is dB, so numerator will be dB plus AD. Right hand side LCM is EC, so numerator will be EC plus AE. Now dB plus AD, dB plus AD, we can write AB upon dB, EC plus AE, that is AC upon EC. So this is another form of basic proportionality theorem. What should be the converse of basic proportionality theorem? That is, if AD upon DB equals to AE upon EC, then we can say line DE is parallel to BC. Original theorem of basic proportionality is, if DE is parallel to BC, then AD upon DB equals to AE upon EC. Converse of Thales theorem is, if AD upon DB equals to AE upon EC, then DE is parallel to BC. So, converse of basic proportionality theorem is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Let us take another example to understand converse of basic proportionality theorem. In triangle PQR, if QM upon MP equals to QN upon NR, then we can say MN is parallel to PR. MN is parallel to PR. Exercise 6.2, question number 1, first part is, in figure 6.17, first and second part, DE is parallel to BC. It is given that line DE is parallel to BC, and these measurements are given. AD equals to 1.5 cm, DB equals to 3 cm, AE equals to 1 cm, and in the first part we have to find the value of EC. So since DE is parallel to BC, using basic proportionality theorem, AD upon DB equals to AE upon EC. Now putting the value, AD is 1.5, DB is 3, AE equals to 1, and EC we have to find. Now 1.5 upon 3 will be 1 by 2 equals to 1 upon EC. So cross multiplication, EC equals to 2 cm. Second question of exercise 6.2. E and F are points on the sides PQ and PR of triangle PQR. For each of the following cases, state whether EF is parallel to QR. Now we have to check whether EF is parallel to QR or not in all the cases. So in the first part, if we calculate PE upon EQ, which will be equals to 3.9 upon 3, which is equals to 1.3, and PF upon FR, which is equals to 3.6 upon 2.4, that is 36 upon 24, which is equals to 3 by 2, and 3 by 2 will be equals to 1.5. So since PE upon EQ is not equals to PF upon FR, so which implies that EF is not parallel to QR. If these two ratios are equal, then we can say EF is parallel to QR. Third question of exercise 6.2. It is given that LM is parallel to CB and LN is parallel to CD. Then we have to prove that AM upon AB equals to AN upon AD. So in triangle ABC, this is your triangle ABC. LM is parallel to CB. So we can use basic proportionality theorem corollary. AM upon AB equals to AL upon AC. Again in triangle ADC, LN is parallel to CD. So using basic proportionality theorem corollary, AN upon AD equals to AL upon AC. So now from these two equations, from equation 1 and equation 2, you can see right hand side is same. So left hand side, that is AM upon AB equals to AN upon AD. This we have to prove. Homework for today is you have to do question number 1 to 5, all the parts of exercise 6.2. Thank you, children.